Mic check, mic check. Alright, I think we're good. So I was just trying to get this to work. Wasn't liking it. You can't see what question that is. 9. Oh, we've got 2 viewers. Greetings. I'm about to 1. Oh, that's up in the page. Let's go. Alright, let's look at this thing. So, the cross section of a 10-meter long tank is an isosceles triangle. The top of the tank's horizontal. Top of the tank's horizontal. What does that mean? Does that just mean it's a straight line? What's happening with the trial? It's cancelled, so you don't have to do a trial exam anymore. So for your rank, you'll just, whatever your mark was before this will be your rank. So obviously first, but like your mark, because obviously we've had 70% worth of exams, that will just become 100%, if that makes sense. Like that 30% that would have been your trial just isn't a thing anymore. No coffee. So in other words, you don't have a trial. You'd just be pretty much waiting for your HSC now. We should just start going through extension 2. That's what we should do. Okay. When the tank's full, the depth of water is 3. The depth of water at time t days is h meters. Find the volume of the water when the depth of the water is h. Okay. Okay. So when I was doing this, I kind of like it wants. I want to be able to draw on it, but I can't. It wants the volume of this shaded part, but you don't know what h is. So I always just start with, I guess if it wants the volume, I always just start with the volume equation and just kind of work with it. It's only 1 mark. The hardest part in here is, I seriously think the hardest part is like the first couple, but they're only worth 1 mark. So yeah, anyway, I'm just going to draw the front triangle actually in a sec. So what I want is the volume of the cylinder. So the volume of the shaded cylinder, I could write shaded, but who cares? So the volume of that is going to be the area of the front times the length. I was about to call that AH, but like that length, I don't know why I'm pointing. So obviously the area of this times this, now that's 10. The area of this is going to be, let's just write A10. Area of that's going to be a triangle, so like half base height times 10, so 5 base height. And it wants it when it's h meters, so it's going to be kind of in general, it's going to have a h in it, obviously. So there's not much else I can do other than, because my triangle doesn't have, like I don't have the base of the triangle, so I just kind of drew the triangle. Oh, I hate that doesn't join. Here we go. So I know that this is 120. I know that that's isosceles. I want to know what that is, so I'm going to call that B. I know that my height kind of runs like h is that. In order to find what this is going to be, then I don't really have enough information other than the fact that it's isosceles tells me that that's going to be, like that's going to be 60, which means those two are 30. So that's 30 and that's 30. And I guess if you halve this, so if I just halve the triangle, I can actually come up with a relationship between this and this with my h in it. So let me draw a new triangle that's right angled. Really wish it was the same thickness. There we go. So then that's 60, that's 30, that's a right angle, that's half B, that's h, and then I guess you could really use any one. This one or this one doesn't really matter, but I'll just use this one. Opposite adjacent tan. Whoa, so that implies that, which then implies tan 60 equals, what is it, half B over H. The whole point is to fill out this. I want to figure out what B is. So I'm going to use this relationship to get B by itself. I know what tan 60 is. That's just, do you know what tan 60 is, don't I? Root 3, I knew that. So that's root 3 equals half B on H. So that's going to be H root 3 equals half B. So then B equals 2 root 3 H. So bringing that up here, that's going to be 5 times 2 root 3 H. Let me get rid of that. H. So then that's 10 root 3 H squared. Okay. I hope that makes sense. The volume. Okay. That was meant to be I. I, Captain. So I'm getting lots of notifications. What am I doing? Show the area of the top surface of the water is given by that. Well, that's really easy now that I found what B is, because that's just going to be, I know that that's B, and I know that this is 10, so the area is just going to be B times 10. That felt a bit more like, that felt like a bit more than a 1 mark. Yeah, that's what I was thinking. But it does set you up for the next mark, because the next mark's going to take like 5 seconds, because the area is going to be B times 10, which was just, that's 10, isn't it? Yeah, because if that's 10, then that's 10. So I know what B is. That was down here. So 2 root 3 H times 10, which is just 20 root 3 H. So that took like 5 seconds. I can understand why that's a 1 mark question. Now this one, the rate of evaporation of the water, this is evaporating, random, is this. Find the rate at which the depth of water is changing at time t. Okay, well, they've given us, see how they've got to show that question right before it with A in it, and my differential equation here has A in it, so I can just directly substitute that. So let's just do that. What have I got? dV on dt equals minus Ka. Okay, but I know what A is. That's the 20 root 3 H. Okay, now what does it want? It wants, find the rate at which the depth is changing. So the rate, I want the rate at which the depth, now the depth is H. See how it's like that, H value. So dH with respect to time is going to be equal to, now I don't have much information about any of this, so this is where you kind of create your own chain rule. Now the stuff that I do have, I kind of write what I have and then kind of like fill in the rest. So dV on dt is something that I have. Okay, now in order to create this H, I need a H on the top, and I also need this to cancel, so I need that to be a dV. So dH on dV. Now obviously I know what this thing is here, dV dt, that's this. So I'll just fill that in, minus K, yeah, I'm just checking brackets, who cares? Root 3, sorry, H, and then times, okay, dH dV. So do I have, don't have an expression for H, do I? dH dV. Is that given in the question? No? Where have I got that? Do I have dV? I need dH. Oh, I have H. dH dV. There's so many D's. Let's go over here. Okay, I have h, don't I? 5h? dv dh. What did you say? From pi I. Oh, I've got v. Oh, you idiot. Yeah, HDV. Why am I confusing myself? Okay. V is 10 root 3. Oh, I'm going upside down. Oh, I'm going to have to flip this. Okay. H squared dv with respect to h is going to be 20 root 3 h. Okay, that means dh dv, which is what I want, is 1 on that. Thank you. So 1 on, and then all this is going to cancel. That means I'm just left with minus k. Okay, we got there. You can get it from part I. Yeah, thanks. I don't know what I was thinking there. Cool. So that means find the rate at which it's changing. Well, it changes at k, which just means it's decreasing as well. How many marks was that? 2. Okay, IOV. It takes 100 days for the depth to fall from 3 meters to 2 meters. Find the time taken from the depth to fall from 2 meters to 1 meter. Yeah, considering it's only 1 mark, I guess your first instinct might be to use this and then kind of start subbing stuff in. But if you just recognize that between 3 and 2 and between 2 and 1 is obviously just 1 meter for both of them, and if this thing's just moving at a, decreasing at a constant rate, then it doesn't really matter if it's between 3 or 2 or between 2 and 1, it's going to decrease at the same rate. So in other words, this is also just going to be 100 days because it's got a constant rate. Yeah, but that's just something you'd have to recognize. And if you didn't get this part as just k, then you kind of shoot yourself in the foot for this part, which is a little bit mean, but you know. I also thought it was interesting that the rate of change of the volume with respect to height is the same as the area. I think that's kind of interesting. And it's kind of the same as if you have the volume of a sphere. If you differentiate that, pretty sure you end up with the equation of a circle, like the area. And if you differentiate that, you end up with the circumference formula. It's kind of like every time you differentiate something, you lose a dimension, but it's kind of like the power rule anyway, like you drop a power. I just think that whole concept is kind of interesting. Okay. This thing looks insane. Area of a sphere. Yeah. Surface area of a sphere. Yeah, 4 and 3. Yeah. Yeah, because you end up with the 4. Yeah. That makes sense. Because isn't it 4 on 3 pi r cubed? And then you differentiate that, you end up with 4 pi r squared. Yeah, that's a surface area of a sphere. Huh. I think the volume of a sphere goes as surface area. Yeah. How interesting. Okay, let's do this thing. This is the picture's going to mess me up, I reckon. Alright. Diagram shows 2 identical circular cones with a common vertical axis. That just means they're sitting on top of each other. Each cone has a height of h, so they're the same. A semi-vertical angle of 45 degrees. Semi-vertical, I've never heard that before. The lower cone is completely filled with water. The upper cone is lowered vertically in the water, and the rate at which it's lowered is given by that. So it's lowered at that constant rate. Where L is the distance the upper cone has descended into the water, right? Man, people got creative with this question. As the upper cone is lowered, water spills out from the lower cone. Okay, show that V equals that. Okay. I think, don't know how that's 1 mark. That's pretty mean, 1 mark. What's the rest of it? 2 marks and 2 marks. I don't know which one's the band 6 question, but I feel like a lot of it is. It's just a lot of interpreting. I'm just going to draw a picture. Is it in? Yeah. Okay. So my picture's shocking, but that's, so from there to there. There. Okay, so that's H. That's my radius. Stop giving in the pictures. No. I'm gonna call this. I'm just gonna call these things. Call that 1. Call that 2. And that's 45 degrees. This little gap here is L. So in blue, I'm going to draw the like this. I'm going to draw this cone, the one that's submerged in the water. Look nice. Okay, that's going to have height L. Let's call this cone number 3. That's the worst diagram I've seen. Yeah, well, okay. Let's take the important stuff out of it. Let's go. Let me take this triangle out. That one. That's all I care about, really, isn't it? Okay. H R 45. Do I know anything else? The right angle. What am I trying to prove? I'm trying to prove the volume. So I guess if you look at the equation, I've got a h cubed and an L cubed. Any equation I'm going to get out of this, the volume, is going to probably give me a h squared. So there must be another h in there. So I'm just going to, like, my equation is going to be, what do I want? I want the volume of the second cone. So the volume of that is going to be a third pi r squared h. I'm going to get an r squared. So maybe I want to write h, r in terms of h. So this tells me that opposite adjacent tan 45 equals r over h. It tells me 1 equals r over h. That means h equals r. Oh, that's cool. So that means this is h cubed. So I guess that's where the h comes in. H cubed comes in. The L cubed, I'm trying to find the volume of the water remaining in the lower cone. So it's going to be this cone minus this cone. So I'm going to need V3 is going to be the same, and using the same argument, if that's H and that's L, then this one's just going to be the same equation as this, just with an L in it. So L cubed. So then the volume left is going to be V2 minus V3, which is going to be exactly what I want, isn't it? I'm going to write pi on 3, so that's what the equation is. Pi on 3, h cubed minus pi on 3, L cubed, which equals pi on 3, side of h cubed minus L cubed. I feel like there's a lot of hoops to jump through to get 1 mark there. Okay. Find the rate at which V is changing with respect to time when L is 2. So the rate at which V is changing, so dV with respect to time, t, when L is 2. Okay, so dV dt. They've named V the lower one, so that's my V2. So that's, they're saying the rate at which, so this, they're talking about this cone, and L is 2. Okay, well they haven't given me much other than dL dt. That rate is 10, so it's going to relate to that. It's going to relate to the rate at which it's lowered. That should tell me, okay. So I want dV dt, but I only have dL dt. So then what do I need to cancel? I've got the dt, I need to get rid of the dv, and I need a, no I don't, I need a dv and I need to get rid of the dl. So they cancel and I'm left with what I want. Okay, so dv on dl. Okay, dl dt, my l's, t's and stuff look exactly the same. dl dt is 10, dv dt is just going to be the derivative of this, isn't it? So that's going to be pi h squared. Is that right? Pi h squared. Oh, I got an L in mine. dv dl. No, it's not that, it's this. Oh my god. Find the rate at which V is changing with respect to time. What's V? The volume, remaining in the lower cone. Oh, that's this. That's the thing I started with. Sorry, the one I just had to prove. So that's the derivative of this. So my hair was just moving my screen then. That's kind of cool. Anyway, so dv left dt, no, dl, I need to expand this. Pi on 3 h cubed minus pi on 3 l cubed. Okay, the derivative, that doesn't exist. The 3 comes down here and cancels that, so I'm just going to have pi l squared. Minus pi l squared. Minus pi l squared. Okay. Times minus pi l squared. So that's minus 10 pi l squared. Okay, we got there. What was the point of doing that? Find the rate at which it's changing. Oh, when L is 2. Okay, so at L equals 2, dv dt is minus 10 pi 4, which is minus 40 pi. Is that it? That was risky because I named everything, but the question already had things named. They said that V was the volume left, which was what I called volume left. So that was my mistake, that thought I was talking about this cone, which is this, whereas actually I'm talking about this cone take away the part that's being submerged. What are my units? So I've got, what's it in? Centimeters cubed, no. Yeah, centimeters cubed per second. Centimeters cubed per second. Alright, last one. Find the rate at which V is changing with respect to time when the lower cone has lost 1/8 of its water. Okay. So, I want the rate at which V, so the rate at which, now V for me is V left, so the one that's actually got water coming out of it, with respect to time, when the lower cone, so the lower cone I called V2, so when V2 has lost 1/8 of its water, so that means it now has a capacity of 7 on 8. That makes sense, doesn't it? Give your answer in terms of H. So it's going to have H in it. The rate at which it's changing. Okay. Quick side note. I do want to find this. Hang on. So when, but I need to know the time that happens. So find the rate that's changing with respect to time when the lower cone has 1/8. So what value for L, so what length downwards would 1/8 of the water have come out? That's what I'm trying to find. So I need to know when the volume of the thing that's left. So I need to know when this cone minus this cone equals 7/8 of the original cone. Does that make sense? I feel like that's a terrible explanation. I want to know when this is 7/8 of this. I hope that makes sense. Please stop me if that doesn't make sense. Okay, so I just substitute that. That's pi on 3 h cubed minus l cubed. And that's, V2 was what? 1/3 pi h cubed. You can see that I've got some h cubes that are gonna, you get it, okay, good. Okay, this is all gonna cancel. That's gone and that's gone. So that's just h cubed minus l cubed equals 7/8 h cubed. If I move everything over, that's going to be l cubed over here. When I move that, I'm going to have 1 minus 7 on 8, so that's just 1 on 8, h cubed. L is going to be the cube root of all of that, so h cubed on 8, which is going to be h on 2. Okay, so L is h on 2. So I want to know what dVL dt is at L equals h on 2. So that's why I said leave your answer in terms of h. The v dt I've got above, so dv dt is equal to minus 40. Oh, that was at L equals 2. Okay, I need the blank one. I need this one. That. So minus 10 pi h on 2 squared. Not really much else I can. Oh, can I something like that? So that's going to be minus 10 times 1 on 4 pi h squared. What's 10 divided by 4? 2.5. I don't like that. Minus 5 on 2 pi h squared. Can I write cubic centimeters per second? Okay. Gee, that was a fun question. All comes down to a perfect diagram like mine, which is undeniably, objectively perfect. Okay. Alright, let's do this last one. I think this one's pretty nice. Okay, show that it's increasing for all values of x. Okay, that should be the easiest question in the universe, especially considering it's an exponential. But f, need a dot there. I guess it just comes down to the argument. It's only one mark. E to the x minus, purely by observation. I know if I differentiate that, bottom cone is lopsided. Yeah, okay. Should have just done that to begin with. No, that's not in there. Is that better? That's actually perfect. I should have done that before. Alright, derivative e to the x plus e to the minus x. You just got to argue that that thing's going to be always greater than 0. I guess the way you do that is just be like, that's bigger than 0. That's bigger than 0. Therefore, that's bigger than 0. Therefore, that's bigger than 0. Therefore, monotonic increasing QED. Alright. Show that the inverse function is given by, okay, that looks disgusting. So I guess we just got to find the inverse. Alright, so y equals e to the x minus e to the minus x. X equals e to the y minus, let's write that as 1 on e to the y. Let's get a common denominator. So that's going to be e to the y all squared, which is going to be e to y minus 1 on e to the y x. E y x equals e to y. This is getting really messy. Oh, this is what I was saying before. Is that satisfactory? This one? Yeah. I can look at the answers. Look at the answers. Holy moly, that question looked disgusting. What was that? Here we go. Yeah, look. They didn't say monotonic and increasing, but seems legit. Oh, did you see that cone? Okay. Yeah, so this is what I was saying before, when you're looking at two things that have exponentials on both sides, and one of them's double the other power, then it's probably the case that you're going to have to make a polynomial substitution. So I'm going to move everything over so that this is positive. E to y minus x. This is going to be confusing. Minus 1 because of this x. Let's let, well, what I need is x's and x's. I've already got x, y's. Lambda equal e to the y. That means 0 equals lambda squared minus x lambda minus 1, we're liking this so far. Always use Greek letters, it's so much better. Okay. Now I need to find, this x is confusing, isn't it? I want to know when this equals, well, I want to know when this equals 0. Yeah, because I need to get, the whole point is to get x by itself, and that's never going to happen, is it? I could divide, oh no, I need to get y, sorry, I need to get y by itself. So by letting lambda equal e to the power of y, I can now swap that out for a ln lambda. So ln lambda is going to equal y. I need to know what lambda is. And this is where the, if you look at the equation up there, it kind of looks like, hey Krish, use ETA. See how I've got that, that kind of looks like the quadratic equation, quadratic formula. And see how I'm trying to find lambda, which is going to probably require me to use that anyway. So let's go. Lambda is equal to minus b. A, B, C. Minus b plus or minus the square root. Now, just consider this. Lambda here has to be positive. So I'm not going to use this negative, but I'll make that clear in a second. B squared minus 4 times a times c, that's going to give me my plus 4, all on 2a, 2. So that's literally where all of this comes from. What's eta? ETA? Is it a symbol? H. I have never ever used that before. How do you draw that? Is it that? Never used that before. Anyway, oh, well, that's kind of it, isn't it? So then I guess I'd just say, since e to the y is greater than 0, that implies that lambda is greater than 0. That implies that lambda has to equal x plus all this on 2. Okay, so that tells me, what does that tell me? Go from the top there. So that means, oops, that implies e to the y equals all that. Which tells me y equals then all that. Probably use absolute values there, but I don't know why they don't. I guess because the negative doesn't exist anyway. So it does say for all values of x. Oh, okay, because the range and domain swap. So the range is positive, which means that the domain of the inverses has to be positive. Just write since lambda equal. Yeah, sorry. Why did I need the since? Oh, to get rid of this minus, because I guess an argument can be made for the minus, but yeah, just write since lambda equals. Yeah, well, if I didn't do that, then I'd still have this, and then I'd have this, and I guess I could just use that argument down here and omit that there, but you'd still kind of have it, I think. Okay, well, that was 3 marks. Do you reckon that's 3 marks worth of work? Potentially. I have a meeting in 6 minutes. Let's smash this last one out. Okay, y equals, oh no, it's not even y equals. What do we got in the equation? E to the x minus e to the minus x equals 5. I don't know how you get in here, Krish, seriously. I swear, it says unlisted, so I don't know how you found. Anyway. Okay, what am I trying to do? I guess it's a clever way of solving this, and it's that I know that that thing's f of x. So this is basically saying f of x equals 5. And since the last question just made me find the inverse, you can kind of, like the inverse is obviously if that's x and that's y. If I just swap it, that's going to be y and x. So I can just write f inverse of 5 is x. So it's kind of like the other way around. But this is kind of confusing because we swapped the variables, so you could consider x to be, like, we're kind of defining the inverse to be y because, like, up here I just like kind of swapped them. So I don't really know mathematically what I should put here, whether it's an x or a y. There were 3 watching earlier. Yeah, that was me with another account. Wow. Okay. That's really weird. I don't know, Xander. What do you think? Do you reckon that should be an x or a y? I don't really. Yeah. I think, I don't know, because we've just come up with this. What did the question say? The question had f of negative x, didn't have a y in it. Does that mean all of these should have been, see, I don't know. I don't know whether that should be an x or a y. I guess at the end of the day, it doesn't really matter. F, I know what the inverse is, it's all this. So I can just write on this side of the equation, ln, with a 5 in it, so 5 plus root 5 squared plus 4, all on 2. That's going to equal x or y. Is it meant to be f inverse? Do you mean this or this? Yeah, I don't know. Yeah, I don't know. Yeah, see, using that argument, this should all be here. Like that should, because then that should just be y. Because I know what y equals, it's this down here. Inverse functions confuse the hell out of me. You've written f primed. Oh, Jesus, sorry. Yeah. Yeah, that's inverse. Yeah, sorry. Yeah, I get confused by the notation because you kind of just willy-nilly swap everything. If that makes sense. Yeah. It's the same argument. I've just got the inverse with 5 substituted. And this is the inverse with 5 substituted. I just don't know whether here you should be writing an x or a y, or if I should be writing anything at all. Anyway, but that's just something I'd chuck into my calculator. What have I got? Then, does it want it exact? Give your answer in 2 decimal places. Oh, that sucks. What's that? 5 plus, what's 25 plus 4? 29. Root 29 on 2. Whatever that is in the calculator. Then 5 plus root 29 on 2. 1.64. 7. Oh, 2 decimal places. Yeah, I don't know. It's got 3 likes, so 2 of those are Krish. Is that right? Okay. Yeah, I don't know. Inverse functions confuse me. I can see why it's a. I don't actually. Do you think that's a band 6 question? I think the only hard part is this part, recognizing this, which appears to be a theme with the band 6 questions because we had that one the other day. Didn't we? Have I? Oh no. Yeah. Yeah. Here we had like exactly the same thing. I don't know. All right. Well, we'll go through next Tuesday. Can I have a look at these? Have a look at these 3. Oh, I really like projectile motion. I don't like this. This looks disgusting. Oh, great, another inverse question. That looks kind of gross as well. All right. I guess I'll see you next week.